And now let's take a look at another example. Again, 4 projects are coming in. What's the probability that they are not all extremely high risk? Okay. 1 could be high risk, 2 or 3 of them could be high risk, but not all 4. So what's the probability that not all 4 are extremely high risk? Okay. Well, we could enumerate all the possibilities of projects that are not all extremely high risk. For example, we could have the first one is extremely high risk, and the second one is medium risk, and the third one is medium risk, and the fourth one is low risk. Okay? Or we could have the first one is medium, and the second one is low risk, and the third one is extremely high risk, and the fourth one is high risk, and so on. We could enumerate a lot of different possibilities. We'll be here all day. It's going to take forever for us to figure out how many different ways are there for 4 different projects to not all be extremely high risk. Okay? But we can think about this another way. If we don't want all of them to be extremely high risk, we can take the complement of all of them being extremely high risk. Okay? So we could do this. We could say, give me 4 projects that are all extremely high risk, and let's take the complement of that. Okay, if we take the complement of that, that gives us room for 1, 2, 3 of them to be extremely high risk, none of them to be extremely high risk. But the one thing that we are making sure we don't have is not all are extremely high risk. Okay, that's what this implies. Here, all are extremely high risk, not all are extremely high risk with the complement. Okay, so if we want this probability, that looks terrible. 1 minus the probability that all are extremely high risk. The intersection of 4 projects, each of which is extremely high risk. Okay? That is 1 minus extremely high risk, 0.02 for each one of those. They're all independent of each other, so we're going to multiply this together 4 times. Okay? If we take 0.02 to the 4th, we get something like 1.6 to the 1.6 times 10 to the minus 7. So 1 minus 1.6 times 10 to the minus 7. That's a pretty small number. 1 minus that still gives us something that's quite close to 1. And in fact, that is 0.9999998. Okay? So what's the probability that if we have 4 projects come in, not all of them are extremely high risk? Something very, very close to 1. As it's very unlikely that we would see 4 projects in a row being extremely high risk. Okay? That probability is quite low for any individual 1 project to be extremely high risk. Then whenever you have 4 in a row like that, it gets even less likely. Okay? 1.6 times 10 to the negative 7. 1 minus that, something quite large, something quite likely. It's quite likely that we're not going to see all projects that are extremely high risk.